everyone. Good morning, good afternoon, good evening, wherever you are. Welcome to Learn with Dummy. In this video, we will explore the practical and logical approach to Spark Catalyst Optimiser. This is beyond technical. In this video, instead of focusing on technical details, we will focus on understanding the concept logically and applying them in a real-world scenario. Imagine we are still working at New York Taxi Company. In my previous video, we saw how to download New York Taxi monthly data for January 24. We have our next challenge now. We have been handed February 24 data. What do we do next? Let's walk through it together. Now, this is the perfect time to start thinking about the catalyst optimization. Let's talk briefly about Catalyst Optimiser, key points and best practices to follow, which we will see in this working example. We will ask why it's important to understand the Catalyst Optimiser and best practices as well. Now, we've been told the Catalyst Optimiser is a core component of Spark SQL that automatically optimizes queries to improve performance. Trust the Catalyst Optimiser for complex queries optimization, but review execution plan to ensure no obvious inefficiencies. So that's what we're going to do. Now, why it's important, quickly, efficiently query execution, resource utilization, scalability, cost efficiency, reliability and consistency, debugging and monitoring, improve developer productivity, adaptability and innovation, collaboration, and knowledge sharing. Understanding the Catalyst Optimizer and following best practices are not just about improving the performance of our Spark jobs. They are about building reliable, scalable, and cost efficient data processing pipeline that can handle in a real world data. So, how to work with Catalyst Optimizer? Working with Catalyst Optimizer in Spark involves understanding how it improves the performance of our queries. Here is a simplified guide to how it works and how we can benefit from it. Analysis. What it does, the optimizer check the query for errors and ensure it makes sense. For example, it makes sure the columns the query refers to exist in data, obviously. Logical optimization. The logical optimization undergoes the series of optimizations such as predicate pushdown and projection pruning. These steps refines the logical plan to be more efficient, which we will see below in a working example. Physical planning, then the optimized logical plan is then converted into physical plan. Makes sense. Considering the most efficient execution strategies, this involves choosing the best physical operators to execute the query. And finally, code generation. The physical plan is compiled into Java bytecode for efficient execution. This ensures that the query runs as quickly as possible. Now, the best practices. This is just the list. It's not enforced to follow in this manner, but it's easy for recording. So we'll quickly go through read data efficiently, partitioning, caching, and persistent, broadcast joins, optimize shuffle partitions if needed, select and filter early if possible, efficient joins and aggregation, review plan, error handling, and schema enforcement. Now let's put this all into action. Here I'm working with Windows 11 Spark installation on a local machine, so I need to import Find Spark. I have created the Spark session. If you're working with Databricks, you probably don't need to. This is where Catalyst Optimization kicks in. So kicks in with the logical plan. When we create a Spark session, Spark is ready to convert DF operations into series of logical plan, as we discussed above. In theory, these logical plans are abstract representation of what we want to achieve with our data. I'm importing some libraries. Now step 2, download monthly files from this website. Now in my folder, I already have downloaded January and February. So that's all good. Download completed successfully. Here we're reading the data. So this is where we're following the best practices to read data efficiently. Here we have a Parquet file, and this is where Catalyst Optimiser kicks in. With df.show, we see some records that it's working. Now this is the interesting part. Spark has by default done some partitions. Now here we see the partitions only with data. This is another way to see the partitions Spark has done by default. So Spark has done 8 partitions, but 5 of them has a 0 records. This is not smart partitioning. So what do we do? How we find how many partitions we need and how to do it effectively? That's the best practice. So smart partitioning, we will continue into identifying, understanding the system resources, because we need to assign the system resources as per the available core. So this script identifies the cores, number of available cores in the system. On my system, it shows that I have 8 cores. So as we've been told, 8 cores equal to 8 tasks equals to 8 partitions. That's what Spark has done here, but it left 5. So we need to work smart and find the right partitions. The other things, we have been told that every partition should have 128 MB maximum. Now this script reads the file, identifies the size, and then tell us whether it's how many partitions we need. Because it's so small, it suggests no partition is required, but that's not true. To work smartly with Spark and to make Catalyst Optimiser work smart, we need to have a smart partitioning. So what do we do next? We go and find the cardinality. Now, in the existing monthly file, there is no cardinality, which we showed previously. But in this data, we will have some cardinality with the month, because we know there is a month 1, month 2, month 3. So that creates the good cardinality. So we're creating a month table, and then from this date, and then we partition by. So this file will write the partition by to month. So here we can see the monthly partition data is created, and there is month 1 and month 2. Now, from here, we're switching to SQL. This is where Catalyst Optimiser will kicks in as well. So we're reading the repartition folders. Now, what we're doing, we're creating a temp views for a taxi trip monthly. Now, this reference one has some lookup data for a location ID. Now we see here that PU location ID is no use for us, because talking to business, they suggested they want to see the report by the borough or suburbs. So we need suburbs, and this comes from this reference table. So I have downloaded the reference table, and that's what I have named location lookup. Now here is suggested above caching. Now I know I will be doing some more transformations and actions, so I'm caching this data frame. Once I do that, it says efficient data handling. So select only columns needed to reduce data shuffling. Makes sense. So what after going through the schema, I identified that, okay, I just only need this many columns. So I selected that columns. Now, this is the good time to talk about the broadcasting. So I'm broadcasting the lookup table because it's the small and it's going through all the partitions to read the data and join them. Now, this is the good time to talk about the predicate pushdown as well. Now, when we did this partitions 1 and 2, predicate pushdown kicks in and it works in a way it does the early filtering. So when a query includes a where clause, the Spark Optimiser pushes these filter conditions down to the data source, such as data table or file format like Parquet. So here, this is the where condition. So we making predicate pushdown work. And then partition pruning as well. So with partition pruning, it's a data partition. Data is divided into partition based on a specific columns or set of columns. For example, in this one, we looked at the months. So we already done the partition by here, up here, by month, and so that's the partition pruning. So what happened that when we say where month 1, it will go just here, it won't even go to month 2. So that's the partition pruning. So this is optimizing Catalyst Optimiser best practice we following. Then we go to the joins. As we know, we're doing the join between table A and B to group by. So we're making efficient use of joins and aggregation using the existing functions. So this is what business wanted, the borrow and the total number of trips. Once this is all successful, we write the file to the folder, which is here, output data, and this is done by partition. This is the default partitions. Now, it's explained that we need to use explain to understand the execution plan and see how Catalyst has optimized the query. We can go to UI as well, and we see the plan. So here is the detailed plan it's doing. So that's all for today. Hope it was helpful to understand the Catalyst Optimizer. By following these best practices, we can maximize the performance and efficiency of our Spark application, leveraging the full power of the Catalyst Optimizer. Thank you for watching. Have a good day. Bye.